Welcome to test corrections for the uniform circular motion and gravitational force assessment. I'm going to go through each part. I want you to follow along, point out where you missed, and make marks on your test or on another page, write out the complete answer. So number one, we had a child in the backseat of a car that is driving down the road. A sharp turn is taken in the road that causes the child to be pressed against the right window. The child asks, "What is pushing me against the wall?" So part A, B, and C all have to do with this part, but part A was bonus. I wanted to see how well you could communicate your understanding. In a paragraph response, respond to the child's question based on your understanding of uniform circular motion. So, a couple big ideas here that I was hoping you would catch on to. In particularly, I was really hoping to see something about the centripetal forces, but there's a major misunderstanding in part A. The misunderstanding is that we need a force in order to make us go against the wall. So if you think about it, you have your car. I'm going to do my best to draw it. Let's say I'm going into the page and going around a circle. Then I would have an acceleration vector pointing inward. Because I'm accelerating that way, that's the direction of my force. But wait, didn't I just ask? The child is asking what pushes them against the wall. So the child is up against this wall. So the child is asking what is pushing them this way. The correct answer, in short, was nothing. Nothing is pushing the child against the wall. Rather, it is the child's desired motion to continue its motion that is not towards the center of a circle, that allows him to move toward the edge of the car. So think about it this way. Instead of the child being pushed into the car, realize that the car is trying to move and the child just isn't going to come with it. So as the child goes this way, the car will instead turn. So what happens is the child gets flung into the side of the car, and therefore a centripetal force takes over, which makes him go in a circle. So the child wants to continue its motion. Making contact with the car causes the child to go in a circle. And since making contact is really an interaction going on between the child and the car, we know there would be some centripetal forces, so we can throw that in there too. I gave you a couple points if you mentioned centripetal forces, but the main thing is I wanted you to realize there was nothing that makes the child be pushed against the wall, but it's their continued motion that, when the car begins to turn, causes the child to hit the wall. So it's not something pushing, rather the child's just continuing its motion until it makes contact with the wall. One other thing to point out is that so the fact that the child wants to continue their motion, this is a concept in physics. I haven't super directly giving you this word, but I want you to be aware that this concept is known as inertia. Newton's first law said an object at rest will continue at rest, or an object in motion will continue in motion until acted on by an unbalanced force. Newton's first law is often called the law of inertia. So even when I'm turning, my object, or in this case my child, wants to continue in their motion. The child hit the car not because of something pushing them into the car, but rather just because the child wanted to continue their motion, and then the car began to turn. The child hits the wall of the car and then begins to turn. This is the same thing that happened to me when I was thrown out of my dad's golf cart when I was in California. My uncle and I were looking for a ball. I was on the edge. He turns left really sharp. I fly out of the golf cart, and then my dad says, "Alex, why'd you jump out of the golf cart?" To which I responded, "I didn't." I had no idea how to explain it at the time. But now with this concept, I see I just kept going, and the golf cart actually left me. So this was up to 6 points. Main concept being nothing, the law of inertia, until making contact with the car causes the child to move in a circle due to the various centripetal forces. Part B now has to do with what are these possible centripetal forces acting on our child. So if I draw another picture, so here's a cross-section of my car, and then you can imagine the child is in here, up against the wall, and that the car is going in a circle this way. So I'm going in a circle, so I must have some centripetal or center-seeking forces, and realize those center-seeking forces must be in the same direction as my acceleration. We actually have quite a few that we could make a case for. There were two main ones that I wanted. So if we think about what's going on with this child, I'm going to draw a free body diagram on a child a little bit bigger. So I would have the force of gravity going up, down. Then I would have the normal force going up. And then from here, I don't care about anything coming in and out of the page of your screen or the surface of your screen, but I care about stuff going left and right because anything going in and out won't matter. And it's at this point I make an argument that tension is coming out of the page or out of your screen or even into your screen, because the goal for the seatbelt, the main thing that would cause tension is to prevent you from flying forward. So really it has nothing to do with you flying sideways. That's why I didn't include tension from a seatbelt in the answer. Also notice normal and gravity are not going in this direction. So we have to think what forces could be going this way to the right. Well, I know my child wants to slide left, so something has to push him to the right to prevent him from continuing to slide left and continuing his motion. So obviously I'm hitting the wall of the car, so we should expect a normal force due to the car. So to specify, I'm going to say that this one is the car on kid. This is the normal force of the wall on kid. So you got to specify between those. And then also, because we are on a surface, we can expect to have friction. So these two were the main ones. Lastly, for part C, if the car takes the turn with a faster speed, what will happen to the net force? How do you know? So I gave you a hint. I want you to use an equation. So you need to justify why you know this will happen. If the car takes the turn with a faster speed, what will happen with the net force? So notice I'm asking you to relate speed to net force. Well, whenever we have net force, the automatic thing that should pop up in our heads is F equals ma. F equals ma, F is my net force, ma is my mass times my acceleration, but I need to relate that to speed. Well, how can I relate this to speed? Well, I'm going in a circle, so I know this is my centripetal acceleration, so we have v squared over r. Mass won't change, radius won't change, so only speed can change. So what we can say is by this equation, if speed, I can even be really specific, if speed v increases, then the net force will increase. And then, so there were a couple main things I wanted you to do. Is I want you to state the logic. I gave you lots of points for the logic and reference an equation or a concept very, very clearly. But I want you to be specific. What will happen with the net force the child feels? So I needed a clear statement of the answer. Therefore, the net force will increase. And that's it.